Hi, good morning or good afternoon, everybody. It's we're going to do the sheet metal webinar here this afternoon. I asked Rosalinda to ask some questions up front, and mainly not necessarily for today's demo, but just to try to make sure that we can put together a little list of what we can do next. My thought today was to kind of run through some of the new changes in Creo 2.0 in the sheet metal package here. I have a little just a little presentation I want to get here. Give me 1 second. I was running late. I had another meeting that I just ran in from. So let's see here. All right, so just real quick, just to kind of give you an idea of what we're trying to accomplish here today and who I am and where I work. So it's from the beginning. So we're a Barry-Wehmiller company, CDT. We're a VAR, so we sell PTC products. We go out and we teach and train and consult. Myself, I actually come from manufacturing, from sheet metal industry, so this was one of the reasons why I had switched over to Creo in the first place, now Creo 2.0, was because of the functionality that was built into Creo. I actually started sheet metal by doing all of the flat patterns on a piece of paper and doing all the math and the little trig angles and all that happy stuff. And somebody gave me a demo of the software, and I was kind of connected. So these first couple slides are just about how to get yourself organized, how to view things, type of question. Our agenda today is basically we're just going to go through some of the changes. So the join walls, which is a brand new technique, how to make a sketch-based form. There's some highlight overlapping geometry, if I can get to that. Bounding box displays, how to make a flat pattern, and then there's some new functionality in the wall extent. Plus, we'll kind of play around with some other stuff as we go. So the join walls with a bend, this is not the way I really think about sheet metal, but in the same sense, there's some great little techniques in here that maybe you can bring to the assembly level and drive some of your sketches out of that assembly and then join them up. It's almost like surface modeling. So we'll go through some of that as well. The sketch-based form is brand new, right? So this is a brand new technique. You used to have to carry around either the punch in a library, which you still can do, or you carry it around as a copied-in feature. So we're going to talk a little bit about how to just sketch it in place. It's real quick and clean, right? Really nice. The overlapping geometry, it kind of highlights. So for some reason you made a cut here and then extended that wall too big and then did the flat, it'll highlight and show you that, hey, there's an interference here. So it gives you the little interference box. In the preview as well, so again, this is it's not necessarily a flat pattern feature, it's not necessarily an unbend feature. This is a preview of the flat layout, and it has the bounding box dimensions to kind of get you an idea of where you're at. And it's just basically a preview. You just kind of turn it on and off as needed. Kind of nice. Creating the flat pattern, create instance technique is back, right? So at one point they were trying to go away from this a little bit, but I think everybody jumped up and said, no, we want to keep it. So we'll do that one as well. And then just some basic, drag ability and moving stuff around, and the highlight of the solid geometry as opposed to a, kind of a see-through geometry the way it was. So it's a much better preview kind of stuff. So let's go ahead and jump into this. So I have Creo running, or Creo 2.0 running in the background here. The only thing I've done is I've turned my background to a dark black, especially over the web. It's really tough to see that white background and kind of see what's going on. So that's the only real change I've made. Basically, I'm running it out of the box, config settings, very simple. So what we're going to do is I have a couple folders here set up that we can kind of work through. So one of the questions that was asked, the poll question, was, how do you start your sheet metal parts? Do you start them by saying file new part sheet metal, or do you start by building a solid and making a sheet metal part? So I'm going to show both of those up front just to kind of give you an idea of both ends of that. We'll start with the convert from solid. So I have a solid model here that's just a block, and I want to convert that into a sheet metal part. So we're going to go up to Operations, Convert to Sheet Metal. we're going to shell, and I'm going to remove this surface and this surface and leave the rest of that as a solid. And when it goes in, we will now be in sheet metal. Now this is still not, obviously still not done, because there's no way you can flat pattern with all these solid walls. So there's this conversion ability, which has been around, but it's now very nice. It's a dashboard type environment. And actually I wanted to do one more thing before I did the conversion. I actually want to add a point, because I want to rip this surface across this surface. So I'm going to add a point here first, right on that edge. And I'm going to use a reference from there, and 1.5. So if we look at that, the point is coming from that surface 1.5 millimeters out. And then I'm going to use the sheet metal conversion tool. So my point's still there. Go to the conversion tool. First thing we're going to do is, you can see they're all icon based too, right? We're going to use the rip, edge rip. Get rid of some of these edges. Drag that one back, use my shift button, and you can see it'll snap right to the point that I created, because again, like I said, I'm going to eventually make a rip across this. And again, control, control, grabbed all those edges. So it's still not able to unfold, because we still have this problem inside here to make that. So that's a rip connect. And I'm just going to grab the two, and you can see it rip. Now I purposely made this point offset from here just to show you that it's going to rip between those two, and it's going to stay pretty dynamic. So when I'm done with this, I can go back to the point and say, oh, you know what, it's not the way I want it. I really want minus 1.5. Get to the other side of that.
Kevin, I just had a comment, I'm sorry to interrupt you, that you're talking too fast for the video to catch up, I guess, for some people.
Okay.
I talk even faster than you, so no worries.
Yeah, I'm sorry. I really apologize about that. I am from the Northeast, and I tend to speak very, very quickly. I'll slow down, and we'll see if we can't get everybody synced up at the same time. So the first part, like I said, I was purely just taking this and converting it to a bend part. I can even do this again. I'll just delete it, and I'll try it again, because the first part's easy, right? Operations, convert to sheet metal. We're in sheet metal. I added a point on an edge purposely because I want the rip to go up, across, over, and up. Right? So conversion, dashboard oriented, right? Brand new UI, great, easy to use. Turn off my data point here. And the first one we're going to do is this top left corner here. It's called the edge rip. So way up here in the top left, left click on that. Left click the first edge, control button with my left hand, left click the second edge, let go of the control button, use the shift button with my left hand, drag it back, tie it to the point, let go. Use the control button again, right, because I'm continuing to add edges to remove, right. Now that's not enough information. That was just the edge rips to actually unbend this. You can see that there's no way I'm going to unbend that thing. So I need to add what they call a rip connect. So that's the second button up here. Grab the point, grab the other point, control, and I have my connect. So that's not a separate feature. That's all built within the conversion tool, right? The idea of the conversion tool gives me a bunch of these tools to kind of help get where I want to go. Now, if I wanted a special corner relief down here, a certain circle or rectangle, I can use the corner relief tool. But this is good enough to get started. Hit the green check mark, and I'm done. Now, at least got it so that it will make a flat pattern, and we can use that preview tool we talked about a little bit. So there's the flat pattern preview button, and it's just a simple button. It didn't make a feature. It didn't add anything to your model tree. It's just simply a button to kind of look at the way this is. And I can make it bigger or smaller, right, just by dragging the corner here. I can add the bounding box information, right? So again, these are just preview type buttons that I can add and just pick. If I want to make a flat state of it now, I can use the flat state. We'll do that a little bit later. I can make a flat pattern like I've done in the past simply by taking a flat pattern icon and grabbing the surface to stay. You check mark, there's my flat pattern feature. So if you're used to using a flat pattern feature, you can go ahead and use it. And it still kind of has the same functionality where when I start a new tool, it goes back to the way it was. Right? And it becomes the last feature in the model tree each time. So some people like to work with that flat pattern in their feature tree, so it automatically reflatten it. Some people don't. That's a kind of a personal preference thing. I like the new tool here where I can just get a quick preview and not actually create a feature. Right? So that would be taking a part, building it in a solid model, and then converting it out to a sheet metal part that's developable. Now, you could build the same feature as a sheet metal part if you wanted to. Right? It'll be a little bit different. So instead of starting as a solid, you just come up. We're going to resave this part here. Is we would come up and say File, New, Part. Instead of being a solid, we'd switch to sheet metal. Say OK. I should have gave it a part name. I just left it as Part 001. Doesn't really matter in this case. Turn my planes on, right? Turn the axes off. I like to see my datum tags, so that's now, this is a Creo 2.0 thing. They've made a separate set of icons to control those tags in case you haven't found that. So I'm in sheet metal. I know I'm in sheet metal because of the extrude and planer buttons here and the flattened flames that are grayed out. Can't have a secondary wall till you have a primary wall, right? So I tend to try to start with an extrude if when you see the shape that I'm going to make here, it makes sense to be extrude as opposed to making a flat wall and adding bends. Because I try to get as much out of these features as I can. So placement, define. We're going to grab the front datum to sketch on and say sketch. Sketcher view is in a couple places, so you have this quick access toolbar here as well. There's my sketcher view. And I can come in and I can just start sketching. Now in the past versions, I would have put my radiuses in, I would have thickened it, I would have added all my dimensions. But you can also come out here and add that stuff in afterwards, right? So it can add bends automatically. So I can dimension to the outside edge or the inside edge, depending on where I put my arrow. Right? And then my green check mark. There's my thickness, there's my green check mark, there's my first sheet metal part. And this was starting in sheet metal. So if we just look simply at the model trees, you can tell that this one wasn't started as a solid because they started with 2 extrudes and then the shell is the first wall. So that was the original question, the poll question. I did not see the answers of the poll. I'm not sure if I can get to them here, just to see how many people were doing it one way or the other. It really doesn't matter so much is which way you go. It's more that you understand that there are 2 ways, and you could do either one. And sometimes it's easier to build a solid shape and try to convert it to sheet metal. Sometimes it's better to make a sheet metal part and just work from that. But like you saw in this one, I made a little hat section. I didn't make a flat wall and then another flat wall and a flat wall and a flat wall and a flat wall. I wanted to kind of get my dimensions in that first shape. And so if we go back to that, I have my dimensions. I could have also one other thing. And so if we delete that, Control D. I could have gone in here and said, well, we're going to extrude this shape, just like I started the last time. I'm going to add the line. Add some fillets. Make them all equal, or at least the inside ones equal to each other, that one and that one equal. And this one equal. And the reason why they're not all equal is because when you're talking about sheet metal, you're really talking about the inside radius is what's important. That's what's, what die they're going to use to actually create this. So for me, I purely want to make sure I'm driving my design to the manufacturing processes. So I've made my shape. I can thicken, right? So I got a choice of which direction. I can give it a thickness, and then I have the outside orange dotted line representing my outside material here. And the reason why I would do this is, again, I purely want to control the dimensions that make sense. I might want outside dimensions to everything. By having this extra thickened wall here, it allows me to go outside here. Oop, make sure what you grab. Zoom in if you have to. Outside there. Outside here. The same thing on the overall height. Here to there. So all my dimensions are going to be the dimensions that I truly want to see on my drawing. My radius, 0.25 maybe on the inside, and the same thing down here. Maybe this is 0.25, right? But again, I got two dimensions because I got this one as an inside now and this one. Now I could theoretically go and make those equal, but I prefer to do this just the way I'm doing it. And then this line and this line might be equal. Or maybe there's some overall dimension, or however you want to control that last wall. This is that design criteria or design intent that I'm trying to build into my model. So if we go give it an overall here, I lose that dimension, but now I got to mathematically go, well, if that's 12 and that's 5, 17, then this is going to be, I want to be, it's going to be like 22 or something. So that was the other way. I could have, used the tools, the options to thicken and add radiuses, but this way I specifically controlled every dimension in that shape right from the beginning. Right? And like I said, I like doing that because when I go to make my drawing, I want those dimensions to come up. So if we go File, New Drawing, and also show the flat pattern here as well while we're doing this. I have my three views. I can pick that first view, go to the Annotate tab, pick the first view, say Show Model, and I'm going to get those dimensions that we just put in the sketcher. Right, so that's my goal, is to make this thing as manufacturable as possible, try to help the guys out in the shop read the prints better, so outside to outside, all the things that are going to make my life a little bit easier. And the guys down in the shop a little bit easier. Obviously, you have your format to this. You probably add a second sheet maybe for the flat pattern, unless you had enough room up here to show the flat pattern. Let's go build the flat pattern. Right. So now I'm ready. I got my part. I want to build a flat pattern of this. Go to my little preview tab. Use the flat state icon here. Create instance. Creates a family table. One formed, one flat. That's all you got to do. Go over back to the drawing. We got to add a second model, which is the family table flat version of this, and then add the view. Right? So drawing models, add a model, in session, because I never really saved this thing. Grab the flat, insert a general view, pick a view orientation that makes sense. So I'm not sure if that's going to be top or front, but top worked. I also like to kind of, if I have room, now there's not going to be enough room on this sheet to do this, but I really like to keep this one-to-one if I can. My part's a little bit too big to fit on here one-to-one. But again, it's really for if I have a good printer and everything's printing correctly and I have the right size, if the sheet metal part will fit on a sheet of paper, it just makes it easier for the guys in the shop to know how big that flat pattern is going to be. View display. I'll go to either hidden or no hidden. In this case, really doesn't matter as long as it's not shaded. I'll add some datum. The view here, the axes. Those are my bend lines, and I might want to add reference dimensions. And because I've dimensioned this thing smartly in a 3D view, I don't want to over try to dimension things. So this would all be a reference type dimension. And that brings up another question that we asked too, and that was how many people are using the default built-in reference and how many are building directly using a bend table, right? Because these dimensions that I got in here are coming from the PTC default, not that PTC created the default bend deduction system, but it's just using a formula. It's not taking anything into consideration as far as the bends, the dies that each individual shop uses. Sometimes it'll be a little bit different from one shop to another. The most sheet metal houses that are actually going to do the sheet metal have their own bend deduction table. So you can drive this flat pattern either through a default and just kind of give the guys a place to go and leave real dimensions in the view, or you could be really specific and work off the bend deduction tables and get exactly what you want. Use this to drive your manufacturing, right? You can drive your CNC tools with this. You can make your programs with this. So this is a great tool. It can be as little as you want or as much as you want. My personal experience, I worked in a sheet metal shop. We used to take DXF files with the program I use and read DXF files. There is built into ProE, there is a NC manufacturing for sheet metal that works phenomenal. If we have enough people that want, a demo of that or a webinar of the NC manufacturing, we take the part from the beginning all the way through to manufacturing and the G code and make some changes and update that stuff. That could be a future webinar for sure, or if it's a more immediate need, get back to us and we'll set something up directly for you and show you where that is. It wants me to change the color scheme. This is going to make me nervous, but let's say go ahead. Change the color scheme to Windows 7 Basic, see what happens. Maybe that'll make my preview a little bit faster too. Scared me though. You never know with Windows. So that was just kind of a highlight between going from a solid to a sheet metal conversion part or a sheet metal start in sheet metal and make the drawings out of that. There's a couple more things I wanted to show here today before we get off. Close these out. Erase not displayed. And that was just some of the basic concepts here. Right, we're going to put this in as a die. So this was the old way kind of doing this. You had a ProE die of this. Still works fine. We want to put that die and press it in place. We're going to go up to form, pick die, it opens up and I got two choices here. One is reference the part, which means like date if it changes. We're going to do reference so I can make a change to show you. Or copy the whole part in, where that way I don't need to worry about the library. It will just stay within my part. And it brings up the assembly type window because I got to assemble this. So I, right off the bat, know that I want that surface right there to the bottom. I'm going to use some datum, so I'm going to turn my datums on. I'm going to use that datum right there to that one. And I'm going to use that one to that one. So the first step is to fully constrain it like an assembly. It still has some of the old dialog box type stuff where I have a seed surface and bounding surface. So bounding, seed is the top, so bottom up. And then exclude surface. So what this does is I can remove things like that side surface, which makes sense, the bottom of the hole, maybe even the sides of the holes. Right? Done references, say OK. And there's my form. Right? So that's a form. That's been around for a long time. Those techniques have been pretty consistent since the beginning, since at least I started, version 15 or 16. But there are some new techniques we're going to get to here. One is the form tool itself, the flatten form. Once you have a form, you have to flatten that form. So it used to be you'd start the form, you'd flatten form, you grab a surface. Well, now there's some built-in functionality to do it automatically. So by default, it wants to just flatten them all. It's giving me a solid preview. I can go in, though, and specifically grab certain ones. So instead of doing automatic to get rid of all forms, there's an icon here to manually grab one at a time. Ultimately, though, it's to get rid of the forms. Basically, so that I can make my flat pattern of that. Right. That's pretty cool. form punch. So this is just another, let me see which one this is. Just another example of putting a form in and getting preview back a little bit quicker. So punch form, it's a dashboard tool. Say open, grab whatever you want to punch with. And this one was built with some interfaces already built into the part, so it knows it wants to assemble that surface. So all I got to do is pick the corresponding surface, maybe that one, then that surface maybe to the top one, and then the middle one right to here, right? So that increased the speed of how fast I can put that feature in there by having an interface built into the model itself. So this would be a library part for your punching, and you have your built-in interfaces, so it's quick and easy, right? You can add some options. Let's say what it looks like now. So preview, you can see none of the radiuses are on here, but I can actually go in here and say let's add right around the placement edges, and you'll see now I get a radius around the whole thing this way automatically, right? And it's going to stay referenced. So if I go back to that form part, so we'll go to the form part here. That's the louver part. So if I go to my gusset form and I say, oh, you know what? I'm going to change this part so that I have some draft on this feature. I'm just going to suppress the round real quick and add some draft. Right click, hold it down to get to the draft hinges, right? It's just like coming up here to say draft hinge, same thing. Grab the front surface there. Add some draft. Bring my round back. Right, so now I have some draft. If I save the model, go back to my sheet metal part. Right, and you can see right now there's no draft on that part. And if I do a Control G, it will automatically update to the draft on the part. So that's kind of carrying that library part information around. Now that means it'll need to find that library part as well. It's not in the directory that you built your model. You have to have a search path to go find that in the library path. That's a whole other conversation. But very easily done. So if you have those questions at the end, we'll email them out and we'll try to figure out how to get the best answer back. Then the brand new punch tool is called Sketch. So now, instead of carrying all those parts in the library and all that kind of stuff, this brand new tool allows you to go in here and just build a sketch form, pick a surface to sketch on, grab a shape, whether it be a rectangle, whether it be a circle, whatever it is, and you can see automatically I get some kind of shape punched through there. And I can add my taper. Because obviously it can't be 90 degrees, it would never work. So there's my taper. You can see how that goes from 0 to 30. I can add radiuses, and I can add the placement radiuses as well. Very dynamic, very updatable, really good. Done. The only issues with all of this stuff is Proe does not do a good job of, figuring out the flat size of that sheet after the form, right? So if you, took a piece of metal and pushed through like that on a piece of sheet metal, it would definitely distort the edges over here because that metal's coming from somewhere, right? It's got to pull it in from somewhere. So that's the one thing that I still have been waiting for some better answers on, but not yet. So flatten, wall extend. So there's some new options in the wall extend part feature. So I can do a couple things here. I can take this edge here, do an extend, and just kind of drag it up. You can use our shift button and grab the top surface and let go. So now it's tied to that top surface. But you notice these little round icons. So these icons are kind of from surface modeling. You'll see them in surface with tangent and curvature and that kind of stuff. So I have the ability to right-click on them and change this. So instead of being normal to the edge, I can say along the boundary. And you can see how that tapers that edge back. Right? So I was adding material. You can also remove material. So I can grab this front surface, even though I said extend, and I can bring that back. Now, personally, I probably ain't doing this. I probably would have went back to my first feature, edited the definition, and changed it, but they just want you to know that that is an available option. And the same thing this way. So we can see how we closed it up pretty nice. You can always go back to my extend. Kind of get that a little bit closer. And looks like maybe a hair longer. Control G, update. Look at our preview window. Bounding box, we get a nice little cut. Off we go. So again, nice extend tools. I'm not real happy about the dragging the material back. I definitely would not suggest doing that. I would have done an edit definition myself. Just trying to show some of the use of the tool, that's all. Close it up. Save it. Let's try one more thing here. Work on it afterwards. Close the model, or it's not displayed. I got the wall join tool. So again, this is another tool. It's brand new to 2.0, and it works more like the surfacing techniques. So I'm still trying to get a little better understanding of where I would use this. Let me show what it does first, and then we'll go back and try to figure out what makes sense. So join. Pick one wall and another wall, and you get the two joined walls. So it looks just like I said before, just like the surface tool, where you kind of pick and choose what to keep, what not to keep. So I looked at this when it first came out, and I wasn't I was having problems trying to figure this out, but at the same time, one of the things I thought about was, what if this was assembled to an assembly that had parts and components, where I could see this bracket being built alongside. There's no parts in here matched up, but I can easily come in here now and expand this and say, let's look at the first feature and say edit definition. So if it's the third or fourth part down here, I can see the other couple in session. And I don't necessarily want to make a whole bunch of references, but at the same time, I can use this technique to kind of get a feel of how close I'm going to be. Maybe I want to pull them back. Maybe I want to move them up, based on an assembly part. So this is kind of where I've kind of come to grips, and maybe that's what they were thinking about when they were talking about this join walls, is that you could really look at something in the perspective of an assembly and control the sketch itself. So you can go in and build that. And build it in the assembly mode. So that's kind of where I see it fits in. I think if you had some kind of a bracket that fit between 2 or 3 components and you wanted to build up to that bracket, might not be a bad way. It's one feature at a time. It's not too heavy of a sketch that it's going to fight with you. You can do it at the assembly level. It's it works out to be a pretty good technique that way. Let's go back here one more time. All right, so here's where my bend deductions are, and I'll go back and do that one more time. I want to make sure I was in the right place. But File, Prepare, Model Properties. So I can set a bend allowance. Right, I can set a K factor, I can set a Y factor, I can set a part bend table. And again, if you're not sure what these are or why they're used, it really comes to what level of the manufacturing are you going to? Are you going to use this shape to drive a CNC tool? If you are, then you got to start thinking about using the bend allowance table so that you're specifically getting the correct overall flat layout, lengths. Your cuts are going to be right. You can bring it right over. But at the same time, if you're just developing sheet metal parts and you're send them to a shop, or maybe you're sending to 5 or 6 shops to get different quotes, best bet is to drive everything with the 3D shape, give a reference for the flat pattern, and I would stop there. Because every single shop that you deal with is going to be a different size and shape. And it might sound, kind of picky, but if you're doing some detail type sheet metal where, 2 or 3 bends and you got some distance off an edge that you try to hold, off on a bend deduction by 5 thousandths over 3 bends, it's 15, 20 thousandths. And again, maybe it's not a big deal for a lot of people, but for some companies, that's too much to be off. So, these are where you're kind of getting a little bit deeper and set that stuff up. Right? All right, so that's about all I have really that I wanted to show today. I really think that if you have more detailed type questions that you want to ask, unless I can see something here. Rosalinda, did you have anything else going on for questions? All right, let me just see if I can read some of these.
I don't see any questions just yet.
Okay. So do we have the answers for the poll questions by any chance? Are they sitting somewhere we can get them to pop up? Oh, there's the polls. I see it. Okay. So the poll questions, it's about 50-50, right? So I have some people starting in solid mode and converting. So it's 52 yes, 48 no. So that's kind of why I showed both sides of that, because a lot of times, it's one or the other. You never know what you're going to do there, right? Let me see if I can get the X. There are a lot of people using Pro E 2 to 4, and then the majority of users were 5.0, and we're starting to see a lot more people going to 2.0, which is a great thing. This Creo 2.0 has some beautiful features built in as far as updates. So that's another one. If you guys that are using the older software want to see some of that, or if you got questions about specifics, feel free. Most people are using the default bend deductions, so 79% said yes to the default bend deductions, 21% no. So that just tells me, the 21% no are probably, sending this out right out to manufacturing and are going to use it. The 79% that said yes might be using outside sources for manufacturing. And it's fine, if you're sending them out that way, that's great. If you want it to be a little bit more accurate, then you got to start thinking about using the bend deduction tables, right? So we have a couple using bend deduction tables here. Are you starting in sheet metal about half and half, and then are you, yeah, so then most everybody else is converting from that. So pretty good poll question. I thought the big thing there was, are you using the default bend deductions? And that kind of shows the difference between people that are using the manufacturing software and the people that aren't. If you're interested, the manufacturer, you want to see a demo of that or how it works, I think that's a great future webinar that we can put together. Other than that, email the questions over and we'll try to answer it. And I appreciate everybody coming for today.
And Kevin, I do have all these.
I'm just about done here.
I have all the questions recorded too.
Okay. So like I said, people, I appreciate everybody coming today. I know it's always, right around lunchtime. We get some food in our food in our systems and just about ready to go. But just feel free to reach out and we'll do whatever we can. If it wasn't exactly what you were looking for in sheet metal, just send some more detailed information and we'll try to pinpoint in on one of the next webinars or one special, we could do a special little demo for your company as well. Thanks everybody and have a nice day.
Thank you. Bye.